Live we are. Space Through the Ages by the one and only Shen. Myself. All right. Oblivious to the gravity of science.
Hold on. Dial down the music a little.
With a commentary from the person in the background. Dial down the music a little, which is exactly what we're going to do. Oblivious to the gravity of science. Ancients strung our system on a beaded wire, ordered in distance from our own world. The sun was closest in this perfect model, traversing one round circle every year. We couldn't see past Saturn, nor Saturn's own glorious rings of reflective ice. Apparitions of wanderers across a backdrop of silent watchers, mysterious entities called stars. I can imagine generations on my fingertips and imagine faces in places I've never seen turned all towards the sky. Caveman returning to a cave from the tribal hunt of a woolly mammoth, glancing up while thanking the gods for fresh food. Baroque-era musicians standing on the balcony of King Louis XIV's palace, gazing up while musing over his next masterpiece. The Chinese astronomer before the time of Johannes Kepler, staring at the fire star while scratching his head in puzzlement. A child on a Texas driveway, tilting her head up, scanning the sky and asking her parents on what those thoughts mean. Generations have come and gone, and I say, hold on to that gaze above. Though your feet are planted firmly on the ground, know that we are all wanderers in space and time.
Awesome.
All right, the invisible entity in the background has said awesome. And with that...
Hey, you're sort of invisible too. Well, up until now.
I am now visible. I am visible. So that I should probably mention that.
Wait a second. What is this? What you always start talking and then what is this? What are we watching?
I'm always starting to talk, and let me backtrack. What is this? SG2 on space. All right, the only weekly space show. Hopefully you're watching youtube.com/shenga/streams. All right. In this particular episode 195, we've been doing it for that long, talking about Johannes Kepler. Now, I keep using the word we. Who is this other guy? Let's see. Hey, how's it going?
Hey.
Nice. So, point the finger at you. Yep. Oh, yeah. And before I go on, I do have to say, I always say, support the show on patreon.com/SG2 on space. Thank you to, and this will, help the show be better. And thank you for our current supporters, Kyle Baker and Sam Welsh. And of course, I will always thank Atum Ra for producing the show for like 2 years before, me diving into doing this on my own. Right. So, on today's topic with, Leonard, let me see, or Dr. Kramer, do you want a name for yourself?
Oh.
No?
Otis.
Otis?
The Doctor of Love.
Okay, there you go. Doctor of Love. See. There we go.
Okay.
Okay, so the Doctor of Love, or Otis, or Leonard's name. Sorry, go ahead.
I was just going to say, how are you doing?
Better than last week, sort of. In terms of how tired I am, which is I'm not as tired, right? Okay. Before I go on, though, I do want to just promote the poem that was written actually by me. So any complaints could be directed at me. And you can go to shenga86.medium.com. The poem is called Space Through Ages. And I mentioned Johannes Kepler in there because
I saw that.
I wanted to point out that he was one of the... So without a context, you might be wondering why any astronomer would scratch their heads. Well, I mean, it's the fact that we will dive more into this, but one motion that cannot be explained very well was a motion of Mars, which sometimes seemed to go backwards if you're assuming a perfectly circular orbit with everything going around Earth. And so, Kepler was able to use a lot of the data that was acquired for Martian motion and essentially help him in deriving what could the actual shape be, which we will go into more detail here. So But without like just me talking blah blah blah.
That's fine.
Leonard, how are you doing?
Well, better than I deserve. Had a good Halloween.
That's good.
This is let's see, this is in case people are watching from the the year 10,000. This is the year 2023, and it's November 1st, and I'm living the life. So,
you are, and you're all in orange and black today. I like that.
I'm color coordinated. Yeah,
you are. So that's good. Now the topic today, which some of us who's interested in astronomy may know, is on the scientist Johannes Kepler. Now, many of us may not have any idea who this person is. So, can you give a little background?
Well, yeah, Kepler is a scientist, one of the top in all of history. So he lived in a very interesting time at the time of the Protestant, when the Protestant Reformation really had come up to speed in the late 16th century. I think he was born in, check me on it, 1571. And to make a long story short,
December 27th, he was born 2 days after Christmas.
Right after Christmas. Okay, yeah. So to make a long story short, but we'll get back to the long story. He sort of determined the properties of orbits in the modern sense of the word, planetary orbits. In other words, he was able to mathematically describe the the structure of the solar system in the modern sense. Prior to him, people thought that the planets, we knew about the planets, from prehistoric times, we knew about planets, but and it was always assumed that they would circulate, they would orbit in pure forms, circles. Everybody thought they wanted the orbits of the planets to be circles, and in fact, so did Kepler. Actually, he was a very religious fellow. He was Lutheran when it was just Lutheran was just coming online. So like I said, he lived at that time where there was a schism politically and religiously in Europe. The Catholic Church was all in power, and they had suffered this Reformation at that time. So Kepler was Lutheran. He was acquainted with the theories of a Copernicus, who lived about 50 years earlier than him. And Copernicus, well, let's back up. So for most of history, people have presumed that the Earth is the center of the solar system. In fact, the center of the universe.
In a poem.
And they presumed that was true. There were other kinds of opinions and different kinds of assertions about it, even in ancient times. I think there was a Greek named Aristarchus of Samos.
Yes, correct.
I hate having to guess that.
Sometimes
I'll go back and listen to these podcasts, and I'll think, oh God, I made a mistake, so I do make some mistakes about things like that. So anyway, Aristarchus speculated that the sun was the center of the solar system and that the planets orbited around the sun. And so that was very prescient, for someone who lived in 480 BC. So and it was not just it wasn't just thinking off the top of his head. He actually did have some observations, and he made some. I'm talking about Aristarchus now, but I think it's kind of interesting. At that time, they had actually tried to figure out, make some critical guesses about the size of the moon and the size of the sun and the distances and so forth. And they were right in some ways and wrong in other ways. But for centuries, that idea kind of percolated below the
it wasn't
surface.
Considered mainstream.
It wasn't Yeah, that's a way. That's
That's
the
the
way
way
to
to
say it.
put it.
The
Yeah.
mainstream idea came from Ptolemy, who had this idea that the Earth was at the center, and that makes sense because we don't feel like we're
I
spinning
mean,
around or anything
yeah.
like that, right? And then also when you look out at the stars, you don't see the stars showing parallax, but you do see unusual motions of the planets. So as you pointed out, the planets, some of the planets, particularly Mars, will
Yeah.
go into retrograde, you know,
Exactly.
and the different
That's a
planets will have a
good way to put it.
retrograde orbit, and we
See that?
understand that today, you know, from our modern perspective, where the sun is at the center and we're co-orbiting with the other planets, and so sometimes we overtake the planet or the other planet will overtake us, and so it has this apparent idea that apparent
The
thing that's going backwards.
Ptolemaic model on the left side
That
was historically, at least in Western astronomy, given as a standard model, so to say, of how the orbits of the
Right.
planets
And you
in
can
sun
see,
work.
yeah, you can see it's kind of a mess. You know,
Yeah.
it's like they I think they have to have these epicycles where the planets are orbiting around, you know, circulating around. And then the other thing about people at that time was they thought of the heavens as being like something perfect. So they
Everything had to
had
be
the
circles.
what?
I said that's why every
Yep.
orbit was a circle.
They had to be circles or some kind of perfection associated with the heavens. And Kepler was had been indoctrinated as a young as a young man
Mhm.
in the 15. He was born in 15. I think his mother was influential. His father was kind of like,
Absent.
let's not talk about his father. His father was a soldier, mercenary, and went off and probably got killed. But
Those
anyway,
guys don't normally make great fathers.
yeah, but
Soldiers and
his but
engineers.
his mom was nurturing and probably influenced him to a great deal. And um, he there was an eclipse, I think, when he was about 4 or 5 years old, and it's thought that his mom took him to a place where they could see this as a lunar eclipse and a comet and other kinds of things. So his mother kind of nurtured him. He did well in school. He did when he graduated from grammar school or however it worked back then. He was German.
Mhm.
Really, he was Germany was not really a kind of an integrated country. It was sort of a conglomeration of different little kingdoms and that kind of thing. But overall, there was something called Holy Roman Empire that kind of governed everything. I actually don't really know the political structure of things. I just know that he was in Northern Europe, and Galileo and others were in Southern Europe under the Catholics. Copernicus, who lived 50 years earlier, was Catholic. And this idea that the sun was at the center of the solar system, it 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 was objectionable for reasons that I think we have trouble fathoming. We have trouble understanding why that was so objectionable, that the Earth, that the sun, this idea that the sun was at the center of the solar system. Um,
Well, I mean,
Copernicus,
different
you know,
times.
Copernicus did
Go
have
ahead.
some data earlier, so we can talk about Copernicus a little bit. Did have some data, and he did come up with a theory that the sun was at the center of the solar system, and he was influenced by Aristarchus and some of the others. And some of the thing that's happening here is that prior to this time, when this was sort of the transition between medieval and Renaissance, right?
Yes.
And
Yes.
so what was happening was a lot of the classic literature, classic writings of the ancients had become available through Arabic sources, because the Arabs were kind of had retained a lot of these.
Yeah.
Uh,
That's why a lot of the fun fact, a lot of the stars have Arabic names.
yeah,
That's
absolutely.
why. Yeah.
So we were able to get, because we were in contact with
Mhm.
the Arabs at that time, um, mostly warring with them, fighting with them. But we did get, there were philosophers and scientists, and we got some of the information, and it also influenced art and other things of that era. But that'd be another story. Um, Kepler was influenced by his teacher when he went to college. He had a teacher. I don't remember the teacher's name. Was something like Michael Moostlin, who was also an astronomer. And his professor, they taught the party line, the Ptolemaic system, but they secretly were they were closet Copernicans. And so
oh my gosh, since it was so unpopular.
Yeah. So Moostlin was his professor in the college where he went to Tübingen,
Mm-hmm.
and sort of indoctrinated him with the Copernican system, and he was fascinated with that, and I think he kind of had that idea all along. He was a very good student, in mathematics and astronomy, and he ended up being a professor at a university called Graz University. And that
was his teacher.
That was his teacher. That was his professor. And what happened was, and the apocryphal story about this, and I think it's something that Kepler wrote about, was that when Kepler was teaching, he was teaching astronomy, and he was showing the relative sizes of the orbits, of what they thought the orbits of Saturn and Jupiter. And so he was looking at the orbit on the chalkboard, or however they presented it to the class, and it suddenly hit him that, gosh, the orbit of Saturn is really big, and Jupiter's inside of that, and I can draw a triangle. It's almost like a triangle will fit around Jupiter's orbit and touch. Yeah, like that, and touch. Wow. That's almost it. Okay, so he thought, oh, I've discovered the design of the universe. Okay,
five platonic solids.
So he started with a triangle, and then maybe he had a square, and then a pentagon, and so forth. And so he was playing with that for quite a while, and even wrote a book about it. And then they started doing
Mysterium Cosmographicum.
Yeah,
Mysterious. Actually, he drew this, if you can believe it. Must have been.
No, I didn't know that. I mean, I've seen that picture. I've seen that picture when I didn't know that he actually drew that. Yeah. Okay. Right. So these are the five. Sometimes it's attributed to Pythagoras, and I've always known them to be attributed to Plato. But of course, Pythagoras came before Plato. And I see reference to Plato in the article there. So anyway, that's what he thought, and he followed up on that for a while. But he finally kind of lost. He lost some. He was very excited about that idea, and he started writing to people all over Europe, and including this one, Tycho Brahe. Tycho Brahe was an interesting character also. He was from Denmark, originally Copenhagen, and he had spent years doing extremely precise, without a telescope, very precise measurements of the ephemerides of the planets. In other words, the locations of the planets relative to the stars. He was missing his nose. He had a bronze nose.
Wait, does this picture have it? Nope, it doesn't show.
I don't think so. But I was, that was interesting.
Look at this one. Oh, look at that.
And he was a very well off, high status astronomer. He had lots of money, and he was very influential. I think he left Copenhagen and started working in Prague under the Bohemian emperor named Rudolf II. I think was the emperor who was his benefactor, patron in Prague. And so he was impressed with Kepler and invited Kepler to come and stay with him. Kepler was running into problems in Graz because of the religious stuff that was going on. The Catholics kind of had a counter reformation, and they took over Graz, and he was kind of persona non grata because they wanted him to convert to Catholicism. And it's just so hard to understand that today. It's like, but one of the things is when you read about these people, it's like they have children and the children die. So people were dying all the time, and so it seems like it was a different kind of. It affected the culture. The idea
Right.
that
This is what he meant by 1597. He moved to Prague, eventually
so.
appointed by Emperor Rudolf II. Yeah. Okay.
Oh yeah, and so so Rudolph, and so Brahe was a pretty good guy, I think. I mean, he was really pretty suspicious of strangers, and he really didn't like to share the data that he had acquired. He knew that he had very, very good data, the best that had ever been accumulated. He did it with an observatory with oversized instruments. In other words, he had a very large astrolabe, very large, one that you could walk into basically and do the measurements so that you could get high accuracy. And I believe he was having, he was
Uraniborg.
So I think that's like 35 miles from Prague or something of that order, something like that. But anyway, so Kepler came to Prague. I think he stayed there for a few months, and then he had some troubles back home. He went back home to Graz to gather up his family, and then they did come back, and eventually they did settle in Prague, and he lived there for a while, and then Tycho died, right? And so another apocryphal story is, Tycho wanted him to validate this theory he had using this data, and so he kind of anointed him, and the emperor at the time kept Kepler on to replace Tycho, which was part of the deal. I think then the emperor died a couple years later, but then the next emperor was kind of cool to Kepler, but they continued on. And at this time is when he started to study the orbit of Mars, and so that's why we're interested in it. Mars is special because it has a high eccentricity. And remember, everybody was thinking that the planets were perfect. The orbits of the planets were perfect, and an ellipse is kind of not perfect. It's sort of
far from perfect.
It's, in fact, you might say, eccentric. So that's a joke.
Nice one. So, ellipses are eccentric.
Yeah.
Yeah.
So he figured out and actually I was very curious about really how they did this. So what they did was, he used the measurements. The measurements were of angles, and they had some distances that they had inferred through by looking at transits of Venus. So they did have some measurements. They knew how far things were away from, in terms of number of astronomical units. They did not have an extremely good grasp of how far the sun was from the Earth, but they did have a good idea about where everything was in terms of the astronomical unit. So in other words, they knew how far away things were. So my take on it was that Kepler would draw a circle on the paper, and then he would try to fit the angles to the circle, and then it didn't quite work, so he had to perturb the circle a little bit. So I think that's what was going on there, and he realized it was an ellipse. And of course, people know about how to draw an ellipse, and so it was an ellipse with the focus, with the sun at one focus, and then the other focus out in some distance away from the sun, and so he was able to come up with an analytical form for determining the location of where the planets were as a function of time. So it's very interesting, and we use this today. In fact, I have some code that I'm working on for GPS and stuff like that. And I was looking at it just today. There's the Kepler equation that's coded in the
So
software.
let's talk about the Kepler equations for a bit then. Let's go down here. So he came up with 3 different laws, right?
Okay, he's got 3 different laws. Okay, the first law I think is something like the orbits are ellipses with the sun at one focus. And then I never remember which law is which in what order, but the period is related to the cube. The period squared is related to the cube of the semi-major axis, the long part of the axis. And then also there's this idea of equal area in equal time. You actually had a picture of the orbit with some sections.
I did. I was trying to find where it says 3 laws, but let's just go to where I was actually showing it earlier.
Yeah.
Here. Okay, so this one is the first law of ellipse. Basically, orbits are elliptical. Second law of areas, which is
right. So the law of areas, and so this pretty so at the closest approach there, you can see from point P3 to point P4 is this took the same amount of time as the transit from P1 to P2, and that's just an example. And so what he pointed out is that the blue areas of those 2 parts of the orbit are equal, so it's equal area. And
radius from the
and I think in reality, so probably how that worked out, he probably had a big piece of paper and he had plotted the orbit out, and he figured it out at this time and this time and then this time, and and it takes months to be able to work up the orbit. And he probably took plotted it out, and then maybe he took like seeds or something, some peas, and filled in the gap with that, and then he gathered them all up and took them over to the other place and found out, oh yeah, see, it's exactly the same area. Or maybe he cut it out but he didn't really know calculus, but he was getting close. Of course, when Isaac Newton got a hold of this, Isaac Newton was able to
Newton
calculate.
used his results to help figure out the
but that was 150 years later.
The third law is this thing, right?
Yeah. So the period of the square of the period is proportional to the cube of that semi-major axis. Semi-major axis is, if you have an ellipse like this, it's that long.
Okay, it's basically from
dimension.
Here aphelion to perihelion divided by 2.
Yeah.
This distance is the major axis. Okay, and then t is the period, basically how long it takes to go around one time, basically.
Yes.
Yeah. So basically, he's saying that this third law is saying there's a relationship between the period to how large the ellipse is, basically.
Yeah. So, and that's of all the planets, so he was able to relate them to all the planets that way. So anyway, Kepler, so he's pretty cool.
Did he come up with this just by, like, you told me that he actually did not know, like, what we now know as, like, the universal law of gravitation.
No, I think that he did think that there was some kind of force involved, and he knew about magnetism. I think he was familiar with Gilbert. There was a scientist, English or Scottish, who talked about. So he was familiar with the work by Gilbert talking about magnetism, and I think he had this idea, and he even wrote that it had something to do with magnetic forces and magnetic. You're distracted.
Go ahead.
You're distracted.
Gilbert. I heard Gilbert. You. Yes.
Yeah. And
I actually did not know that.
So he thought it was something having to do with magnetism. He got a letter one day. He got a letter from Galileo in 1610, and Galileo told him about the moons that he observed around Jupiter, and Kepler, said, "Hot diggity! I mean, that's awesome."
That's exactly how he said it too.
Yeah, I think it's pretty much like that. So he did correspond with Galileo. He didn't get in trouble the way Galileo did. Really, being in Protestant land, I think, kind of protected him. from that. Also, he didn't really make the same kinds of assertions. Neither did Copernicus, for that matter. Galileo's problem was that he was asserting an ontology. Like he was saying, "Look, this is how the solar system is. It really is like this."
Mm-hmm.
And people didn't like that. One, because he didn't answer all the questions exactly. He was wrong about some things. He didn't explain why that we didn't see parallax. So, and I, I don't think we're really hearing the whole story about what happened with Galileo, but Galileo's for another day. We're talking about Kepler.
We did talk about Galileo in a
Yeah,
previous episode, which I will share the
yeah,
link
we did.
soon.
And Kepler, so that was he did most of his, like most scientists, he did his really heavy lifting when he was around 30, 25 to 30. He became a professor when he was 23. So
Wow, that's pretty
um,
impressive.
yeah, and
He did
he
some
had.
other. Do you want? Well, do you want to talk about his other work or?
Sure. Yeah. Okay. You bring up optics. He was one of the first to recognize. He was the first to recognize, the nature of how the eye worked. I think
Mhm.
he did dissections, like of, maybe eyes from the butcher shop or something like
We
that. And he
have
looked at.
something known as a Keplerian telescope for some reason. So
Yeah, it has
yeah.
multiple lenses. I don't know what's special about the Keplerian telescope, but he did really define modern optics. He discovered that um, the light, when it enters the lens of the eye, goes through a lens and then
Mhm.
it's projected onto the retina inverted, so it's upside
Mhm.
down. So actually, it's kind of like, you know,
Our head actually, our brain flips it around, right?
our
Like,
brain is
reverse
able
it.
to interpret it, so that it's not upside down for us. It's right side
Right.
up. It kind of blows your mind, doesn't it? It's like,
It
wow, yeah.
So our
So
eyes with our lenses, when it goes through, it actually a lens, it goes through, it inverts the image. So whatever we
it's
see
it's
is actually upside down. Yeah.
it's an inverted image on your, and so he recognized that and realized that. He studied snowflakes. He
Oh, tell
he
me
he
about
wrote
snowflakes.
he wrote, well, I don't know, there's a lot to tell, but he did write a whole lot about snowflakes because he had some lenses and he was able to look at them carefully. And of course, um, where we live in Houston, we don't get snow very often, but when it does snow, and if it's like, get out there and have a look at snowflakes, and you'll see that each one of them appears to be different. So they're all different.
It's,
Um, and so he
that's
he
so
wrote some
interesting.
things.
I had no idea he investigated snowflakes.
He investigated snowflakes. He did something on
24
snowflakes.
pages of closely argued text and a few simple diagrams. Kepler attempted to find an answer to the question of why snowflakes always fall as small six-cornered star shapes. There must be a cause, he suggested, else why aren't some four, five, or even seven-sided?
Uh-huh.
Perhaps the hexagonal shape allows for the most efficient way of packing together the flakes of snow. That's so
Well,
interesting that he wrote
and
24
so
pages
and
on
so
this.
there is, yeah, so there is this
Believe
concept
that.
of Keplerian packing. Ah, there it is, where the most efficient way of packing spheres together, and so he investigated that. So he was kind of a eclectic scientist. So a lot of interesting things. He had a
That's
lot of
so
personal
interesting.
problems. He was not really he I think he struggled when he was growing up. They didn't have a lot of money. Um, and he did better later on. But his wife died. I think his first wife died
Hmm.
sometime between 2000 si-
Over
1604
here.
and 1610, and then he
Right.
married another. He married another a woman, and she had six children. I think six children altogether. But people were always dying from stuff, and so they would get smallpox, and it's
I mean,
in
back
fact,
in the 17th century
yeah.
or 16th
I mean,
century, people
Kepler
just
was
died
crippled.
all the time.
Yeah, Kepler was crippled by smallpox when he was an infant. His eyesight was kind of impaired because of that. He had some neurological issues with his fingers and hands. Um, so yeah, but that's about it. you know, Kepler, like I said, he didn't invent calculus, so he didn't have
He came up with a. Go
yeah,
ahead.
he didn't have the forces right. He knew there was something going on, with the forces between the bodies in the heavenly bodies, but he didn't relate it to gravity the way Newton figured that out.
Right.
And
But he did say apparently contributed development of infinitesimal methods of numerical analysis, including iterative approximations, infinitesimals, and early
absolutely,
logarithms.
I should mention that, because what part of the problem with doing the Kepler, what they call Kepler problem, is you end up with an equation, and also have to point out that Kepler had the full way of doing algebra and trigonometry. He knew about what we call sines and cosines and tangents. He knew all about that. They were using that at that time. Okay, but he ended up with an equation where you have something like the cosine of an angle on one side of the equation and the angle on the other side of the equation. It's like eccentric anomaly. So he solved it where you have the average motion going around, and then you would do something like a perturbation of that to come up with the actual angle and distance that it had from the focus. And so you end up with an equation there. Actually, there's the equation. So that's Kepler's equation. So you have the sine. I said cosine. Sometimes you can frame it that way also.
M equals E minus little e sine of E.
Right, and so you're after E, the capital E. The little e is the eccentricity of the orbit. Okay, and M is like the mean, what they call mean anomaly. That's like an angle that goes around at an even rate all the way around. So you can just figure that out by multiplying. But it's that capital E that you're after. And so to get that, you have to do some kind of very sophisticated iteration. And like I said, I happened to be just looking at that today.
Kepler's equation, transcendental equation, because sine is a transcendental function, means it cannot be solved for E algebraically. Yeah. So even if you know big M and little e, and you try to calculate what big E is, you can't solve that analytically.
So what you can do is you can guess. Like you can solve for E as a function. You can put E on one side of the equation, and then you can guess E, and then iterate. So you take E, and you'll get M minus, and then you'll get an E, another E, and then you take that E and you plug it back in, and you do it recursively. And then there's also something called Newton's method, which is like a way of solving it by it's by forming an iterative method. So, but I'm not aware of any kind of right, method. And that's the way I do it.
Yeah, and then this is the other one, right? The fixed point iteration. Is that what you were saying earlier?
So you can just cast the equation and then just repeat it. And it happens that if you formulate it, correctly, it'll converge on the right answer.
Yeah. You can do this. This is what you're saying. The other method, you know a little bit of calculus, and you can use the method. So
I hope our audience is kind of like not zoning out. I mean.
Hey, this is, well, to me it's interesting, but you know what? Talk too much math and somebody might be zoning out.
Yeah.
All right. But for anybody you could check out this Wikipedia page, which has, more in depth a little bit.
Yeah.
But
so, I haven't read any books about Kepler or anything like that, but just
So just saying that, if you get an equation named after you and you got 3 fundamental laws named after you, you must have contributed to something.
Well, yeah.
So
when Kepler was my age, he'd been dead for 6 years. So.
Oh my god. Hey, that's kind of a funny joke here. Kepler was my age. He would have been dead for 6 years. But
anyway,
people back then their lifespans were rather short. So how did
Yeah,
he die? Let's go into that slightly.
I
It's
I
just
don't know how he died. They did say that his mentor Tycho Brahe, or
he died from some
the
urinary
so
infection,
yeah, they say, but
or they say somebody may have poisoned him with mercury.
yeah, maybe like Kepler.
Yeah. Apparently they didn't get along very well in some
No,
areas.
I don't think that. I think Tycho had some trouble getting along with a lot of people. But I don't. I think that they did have some argument early on, and that was part of the reason for him running back home. And then when he got home, there he got in trouble, or somebody was sick. His wife got sick, children got sick, and you know how it is. It's life.
Yeah.
And back then it was life and death. So it wasn't just getting sick. When you got sick back then, it was like, you're just rolling the dice. So, but yeah, they did. I think they did have some ups and downs, but Tycho did really, I think, anoint him and want him to be
The
his
successor.
successor.
Yeah.
And the emperor assigned him to that task. The emperor was kind of like kind of like a patron of different kinds of arts and things like that. And another thing was they were doing horoscopes and astrology.
Right.
That seemed to be important to the
Well, I
people at
thought
that
back
time.
then when even if you're appointed to be an astronomer, you still ended up doing astrology part of the time.
Yeah, right.
So,
So,
it came with the job.
so I guess the final thing I wanted to say about it. So part of the revolution that occurred in this epoch was, remember, we mentioned about in medieval times and right up to this time, the time we're
Mhm.
talking about, not today, but this time of Kepler,
Right. The
the
16
heavens were considered like pure, perfect place.
perfection.
And Kepler was a contemporary of Galileo, and they kind of demolished that. Um, uh, Kepler observed, and the whole world really observed a nova, a supernova that one
Oh, yes,
in
that famous
and
supernova.
so
Yeah.
that's not supposed to happen. The heavens are supposed to be constant and perfect, and the only weird things that happen are comets from time to time. And it's a really, but here they saw a star
Mhm.
appear, right? And so that means it's like a place. It's like something different. Um, it brings it kind of not to be perfect anymore. And then the other thing is Galileo, he looks at the moon and he draws pictures of the moon, and he sees it's a place, with mountains and stuff like that. And then this was a watershed. This was a time when people at the Renaissance realized that there's something other than the earth, and that there are other places, that these are places where that are like the earth, instead of some kind of heavenly or ethereal realm. Um,
That's so
so
interesting
that's
that,
the other thing I wanted to point out.
yeah.
Yeah.
So this you can find it. It's called, I mean, that's not the official name. SN1604 is the official name, but you can
Yeah.
also known as Kepler supernova, Kepler's nova, or Kepler star.
Yeah.
It's a Type 1A supernova. Which, by the way, if you go back a few episodes, we talked about what
We
supernovas were.
talked about and a type
Yeah.
1A is a
Yep.
is a
That's a
yardstick, a
that's a
metric that we can.
yeah.
Right. Hmm.
So, but yeah, I mean, like nowadays, you can see the remnants of the supernova, the nebula.
Right. In
Um,
our lifetime, we haven't seen anything like that, but they
yeah,
do happen every 100 years or so.
right. So that's definitely something.
Yep.
Yep. And anyways, it was surprisingly enough, right before Kepler, Tycho Brahe saw one too. Actually, the
Yes, I think
1572 one.
there
Yeah.
was another one before,
Right.
right about the time that.
It was just purely coincidence that they were able to, like, Kepler saw like two of them, basically, sort of.
That's right. And well, Kepler didn't see the one in
Oh
1572. He was
wait,
only
he
1 year
wasn't
old.
alive.
Yeah.
Yeah, you're right. You're
Well,
right.
he was alive, but maybe his mom told him about it. Okay.
Yeah, yeah.
So anyway,
But anyways, so that's interesting. Anyways, reprints overseen by Johannes Kepler in 1602. Yeah. So this uh it's interesting that the whole notion of the heavens changed at that time. It was a very pivotal era in astronomy.
Yes.
The 1600s for sure.
Yes.
So, all right. I feel like when you say don't go over 30 minutes, we do. But
Yeah, I just see we're 45 minutes in, and we've been struggling to try to keep. Oh well.
all right.
I mean,
Well,
the thing is, I have so much fun, with this that.
So, fun fact for everyone: if I can ever find this, in high school, I actually wrote a biography of Kepler's based on Kepler's discoveries. I mean, like I did a bunch of research on him.
Oh.
And I won like third prize for some history writing contest. And
Well
I got
done.
I got a book from it, which I've barely read, like some history book. But
Yeah.
anyways, all that is to say that I do know some stuff about the sky because did that kind of work, and also given the fact that anybody who studies aerospace would know who Kepler is. I would certainly hope so.
Well, if we solve for orbits, usually we'll do Kepler equation for
Exactly.
where it was used is in calculating the locations of the GPS satellites. It's almost like a recipe that you follow
Mhm.
using the ephemeris that's transmitted from the satellite. And so you take all these parameters, but in one of the places you calculate the eccentric anomaly in exactly the way that we were just talking about. So anyway,
We can talk more into that in the future. For now,
another exciting episode.
indeed. So for now, I'm going to have to tell you guys. Shall we conclude,
I
Doctor
think
Love?
so. Yes.
All right. We'll save the weird alien stuff for next time since we're already running late.
Okay.
Or look up because you never know what you will see.
That's right.
You know what? That's so true because look at what Kepler saw.
Yeah, a
Uh,
type 1a supernova.
but not just type 1a supernova. Being able to see all the. I'm not saying anybody now can make such major astronomical discoveries just from the telescope, but maybe you can. I mean, being able to understand and see the heavens, right? So
Yeah.
yep. So don't forget to look up. We will be back next week with another exciting episode. Remember to follow this on youtube.com/streams. You can find SG2 on space. It'd be a channel or rather a playlist. So you can follow that and you can follow my channel. And
Yep.
also, support the show, patreon.com/SG2 on space. And regardless, subscribe and share and all that good stuff. All right. We'll be back next week. So with another exciting topic.
Namaste.
And
Shalom.
Nanu, Nanu. So says Alicia. Wonderful. I think I know what that means. All right. Okay. Take care, everyone.
Bye.